All right, it's Mr. Robs.
Mr. Cole?
Right, and now we're still talking about quadratics and vertex form, but now we're going to talk about specifically the domain and range. Okay, and so domain. When you hear domain, Mr. Cole, what do you think about when you hear the word domain?
Okay, well, domain is the set of x values basically that are possible on that graph.
X is possible.
Okay, and remembering that graph, we're only seeing a little section of that graph, but that graph obviously carries on going, getting wider and wider as we carry on.
Right. And when I think about domain, I think about vertical lines as well. And when I look at my vertical line, this vertical line here.
Horizontal there.
Oh, I think about verticals. It's going to touch the graph here, 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 and here.
Oh, okay.
Okay, so I think it touches the graph here. So this x value works. If I take my vertical line across, this graph would extend out eventually, and it would touch this vertical line. And I asked myself, is there any place that this blue line wouldn't touch the graph? The answer is no, it would touch it everywhere. That tells me then that x can be any real number, can be any number. The way we say that in fancy math symbols is we go x belongs to the set of real numbers. And okay. Any number can work. And so vertical lines is what I think about for domain. When I think about the range, that's the set of y values.
Yep.
Okay. And this time I think about horizontal lines. Horizontal lines. And I look and see where in the world does this horizontal line touch the graph. It touches, touch, 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 touch. Oh, it stops. So there is no y value here that's going to touch the graph. So somewhere it changes. And so it's right there at the vertex is where y values start to be on the graph, touching the horizontal line.
Okay. So it can be at that vertex, right? Because it does touch when y is 3.
Right. So we could say y is 3 or smaller numbers. If we want to put it in math form, we say y is less than or equal to 3. Because this is my vertex here. 2, 3. 3 is as high as it will ever go.
1, 3, I guess.
Oh, 1, 3. I can't count. 1, 3. Okay. So, all the way up to 3. So domain is horizontal lines. Range, I said that backwards. Domain is vertical lines. Domain. Oh, what am I saying?
So
I'm getting my colors mixed up. Domain, I look at the vertical lines. These ones here are my domain.
Just everywhere that touches your vertical line.
Right.
Yeah.
And range are my green lines here. My horizontal green lines. Seeing where it touches the graph.
Okay.
One more example.
Let's go.
Okay, so we have the function in this form, and we wish to find the equation when this is the vertex and this is a point on the curve. Well, vertex tells me right away, I know the vertex in general form is hk. And so my vertex must be -1, 4. I can plug that in. So I get y is equal to ax. Careful my signs. Negative, negative makes a positive. Squared plus 4. Now my problem is I still have an a here. What am I going to do to find a?
Okay, so we've got a coordinate which tells us an x value and a y value where this equation should be true. It should work when y is 1 and when x is 2. So we've only got one unknown here. We should be able to find it algebraically. Very nice.
So I get 9a plus 4. Subtract the 4, I get -3.
Yep, equals 9a. So a equals
negative 3 over 9, which is negative 1/3. And so my final equation will be y is equal to negative 1/3 x plus 1 quantity squared plus 4.
nicely done.